Resultant force. The combined effect of several forces is known as the resultant force. Since forces are vectors, we must use vector addition to find the resultant force. Therefore, before you work through this video, you will need to know how to use vector addition. If necessary, you should refer to the following video, which covers this topic. Thanks for watching this video, and don't forget to like, subscribe to the channel and activate the notifications. It's very important to the continuity of this channel. We can represent forces using arrows because a force has a direction as well as magnitude. This means that force is a vector quantity. Usually, more than one force acts on an object. These forces can be added together to give the resultant force. The resultant force is a single force that has the same effect on the object as all the individual forces acting together. The general rule to add two vectors is: draw arrows end to end, so that the end of one is the start of the next. Join the start of the first arrow to the end of the last arrow to find the resultant. Forces which act along a straight line can be added if the forces are in the same direction. These two forces are in the same direction, then we can add them to get the resultant force. The resultant acts from left to the right. Forces which act along a straight line can be subtracted if the forces are in the opposite direction. These two forces are in the opposite direction, then we can subtract them to get the resultant force. The resultant acts from right to the left. Now let's see how to add two perpendicular forces applying the general rule. Find the size of the resultant of two forces of 5 newtons and 12 newtons acting at 90 degrees to each other. Draw arrows end to end. Join the start of the first arrow to the end of the last arrow to find the resultant. The resultant is the hypotenuse in this triangle. So we have to apply the Pythagoras theorem. So the resultant acting on the block is 13 newtons. To find the angle that the resultant makes with horizontal, we use trigonometry. Two small tugboats are pulling a large ship in a harbor as shown below. Find the resultant force acting at the ship. Join the start of the first arrow to the end of the last arrow to find the resultant. Apply the Pythagoras theorem. Now, let's consider the case in which a body is subject to four forces as follows. We choose a set of axes whose origin is the body in question and draw all the forces on the body. We can sum all the four forces using the component method. To find the resultant force, we sum all the forces that go in one direction and then all the forces that go in the other direction. Do not forget the signs. Upwards is positive and downwards is negative. To the right is positive and to the left is negative. The angle that the resultant makes with horizontal can be calculated using trigonometry. In the previous case, we have forces that are all parallel to each other or are at right angles. It is time to consider the case where a body is subject to forces that are not parallel. The force 1 has a magnitude 7 newtons and is applied at a 50 degrees angle, whereas the force 2 has magnitude 5 newtons and is applied horizontally, as shown in the diagram below. We draw coordinate axes. Next, we determine the x and y components of all the forces that act on the body. We write the force 1 in component form. We write the force 2 in component form as well. When we sum all the x components, we will get the x component of the resultant force, and the only component in the y direction is the y component of the resultant force. The magnitude of the resultant force can be calculated by applying Pythagoras' theorem. And the angle that the resultant makes with horizontal direction can be calculated using trigonometry. Finally, let's examine the case in which a body is placed on an inclined plane and it is subject to more than two non-parallel forces. To solve problems about a body on an inclined plane, we need to break the forces up into components that point parallel to the slope and perpendicular to the slope. We do that by changing the coordinate system. In the original coordinates, the y-axis is oriented vertically, the x-axis is oriented horizontally. If instead the coordinates are oriented so that the x-axis is along the inclined plane and the y-axis is perpendicular to it, the problem becomes very simple. Pay attention. Next, we determine the x and y components of all the forces that act on the body. Take a look at that, because many people do not understand the solution from that point on. If we extend a line from the head of force 3 to the left a bit, we create a nice right angle triangle, and we know that the angle at the top of the triangle must be 50 degrees, since the angles have to add up to 180 degrees. Since we know the magnitude of the force 3 and an angle on the triangle, we can use basic trigonometry to calculate the vertical and horizontal components. We write the force 3 in component form. When we add the x components, we get the x component of the resultant force, and the y component of the resultant force is 0 because the y components cancel each other out. The resultant force has 1.1 Newton of magnitude, and its direction is parallel to the inclined plane.